negative 70 degrees in standard position. So we're going to draw it down here. Okay, so there's 70 degrees. Or sorry, not 70, but negative 70 degrees, and it locates that spot down here. Okay, and again, it's important that we recognize the position of that spot. Now, the quadrant here is going to be quadrant 4. We usually call that Q4. Okay, so that quadrant is Q4. And then when we look at this, now we want to relate this back to trigonometry or triangle geometry. So we need a triangle, and our triangle is going to be made by the x and y coordinates. Okay, now the triangle, because we're now using x and y instead of adjacent and opposite, we can actually determine the direction of this and then apply this and find positions in all 4 quadrants. So when we look at this though, this triangle and this circle has some symmetry about it in each of the quadrants. So it has quadrant symmetry. So there's some symmetry in quadrant 1 with this position. There's symmetry in quadrant 2 and 3. So it says here, find the angle that has the same x coordinate. Well, if I want to find the angle with the same x coordinate, I find my x positioning here along that line. And on the circle, that blue dot has the exact same x coordinate as the green dot. I'm going to draw that in. So there it is. Now that spot there shares the same x coordinate. It's a different position, but there is symmetry between those two positions. Okay, the x coordinates are the same. In fact, the y coordinates are the same, but in this case here, instead of going negative y, we're going to go positive y. And maybe we should indicate that. So let's make that negative y here. And going to the blue, we're going to go up the same distance. So although they represent different positions, there's definitely symmetry that connects those two spots. Okay, so that blue then represents the x coordinate, the angle with the same x coordinate. In fact, we can find that angle because we know symmetrically that's going to go the same distance in the positive direction as it did in the negative direction. So that's going to be a positive 70 degrees. And again, we're just using the fact that these two triangles are symmetrical, so they share the same pieces. Maybe not in the same directions, but they share the same pieces. So we want to find the angle in quadrant 3 that has the same x coordinate. Okay, well, the same x coordinate, I'll do this one in purple here. The negative x coordinate means we're going to go in the same direction but negative, and it's in quadrant 3, so we're going to go down, so it's going to look like this. So it's going to be negative x in this direction. Now, because it shares the same x coordinate in the symmetry of this circle, we know that it's got to go down, and we're looking at this point here. So it's just symmetrically across that y-axis, and this symmetry and this reflection here allows us to get this triangle shape, this reference triangle. And we can find this angle then now by using some of this symmetry. There's lots of ways to do it, but we can say that we could use a reference here. Well, this is 180 degrees, and we know that this angle in here is 70 degrees. So the positional angle, again, remember we're talking about the position, the angle that locates this position is going to be 180 plus 70, so that's 250 degrees. Okay? So the positioning can be found by using some of the symmetry given in the diagram. Okay? We know that if the x coordinates are opposite of each other, there is this triangle symmetry in those quadrants, and we can use that symmetry to find the position from 0 degrees. Now, some people may have done it differently. They may have found the 20 degrees in here, this spot here, and said that's also 20 degrees, and they may have gone backwards from 270 they would maybe gone backwards 20 degrees to get to the same position of 250 degrees. Now, regardless of how you get there, we're going to use symmetry, and wherever you end up is going to be the same position. Okay, so the last one here says, which quadrant has the same y coordinate as negative 70? Okay, well that one's going to be this y coordinate here. Negative 70 shares these two y coordinates, so that's going to be the same angle at 250 degrees. And there is one more triangle that's the symmetry in quadrant 2, and we know that that's going to be up here. Okay, and I'm just going to draw that in. Okay, this isn't part of the problem, but we know that there's a point up here that's symmetrical, and that point has a rotational position of, it's going to be 90 degrees plus 20 degrees, or 110, or we can say, because that this angle in here is a shared angle of 70 degrees, that's our reference angle, we can say start at 180 and go backwards in position, rotate backwards to 70 degrees to 110 degrees. Okay, so there's this quadrant symmetry that's involved when we're looking at circle geometry, circle trigonometry now.